I think it's going. Yep. All right, so today, go ahead and start with a triangle. It's kind of better, I guess, to start with a cube. Yours doesn't have to look like mine, but we got to start somewhere.
Okay.
All right, today we're going to create our point of concurrency based off of perpendicular bisectors. Okay, that's our line segment today is a perpendicular bisector. So, what's a perpendicular bisector?
Two bisecting lines that intersect each other perpendicularly.
Okay. Okay, so help me out. I want to draw, I'm thinking about it. When I start from a vertex, where should I go to draw the perpendicular bisector? Opposite side, then what? What else has to be true?
90 degrees.
It has to make right angles, so that's the perpendicular part, but where's the bisector part come into play?
The other line that you're going through.
What? You're right, it has to be 90 degrees, but what else has to be true? Where's the
go
bisect
past
part?
the triangle.
No. What does it mean to bisect?
Cut through the
Cut,
middle.
and the bi means in half. Very good. Very good. So this line right here that I create has to be perpendicular and cut it in half. Cut the side in half, okay? So how can I use my GeoGebra tools to do that?
Measure the sides.
No, we've actually used some tools earlier that could help us with this. We're going to have to mix a couple of these. What do you think, B?
Perpendicular line.
To what? Okay. What? Alright, go to construct. Go to construct and highlight over these and see what you see. Highlight over these buttons.
Midpoint.
Okay, perpendicular line, that would help.
Midpoint.
Midpoint, we can kind of, we can mix perpendicular line with midpoint. We did midpoint earlier. Midpoint and perpendicular line. Oh man, I'm so glad we're on GeoGebra and it does it for us. Perpendicular bisector. But you're right. We could mix midpoint and perpendicular line and that would work too. Okay, but might as well do the shortcut and go to perpendicular bisector. Perpendicular bisector. So what we're going to do is we choose the vertex we want to come from. Oh shoot. Select 2 points or one segment.
What?
Oh no, it doesn't come from a vertex. Sorry. You just select the segment that you want. That makes sense. It can't come from a vertex. There we go. So there we go. Huh? Okay, well let's confirm. Let's make sure that this is our perpendicular bisector. So it doesn't have to go through the point. I forgot about that. That was my bad. Okay, so let's make sure that this is a perpendicular bisector. Remember the intersect button so I can put a point there? So hit the intersect button beside points and click the segment and our proposed perpendicular bisector. Now how can I confirm, how can I make sure this is the perpendicular bisector? Do what? Good. So let's check that it has right angles. Do you remember how to do that? Yes. Go to measure angle. And you could choose 3 points or just choose 2 lines. Easier to do 2 lines. Okay, good. That's 90 degrees, so I feel good that it's perpendicular. Now how do I check that it's a bisector?
Goes through the middle.
Yeah, so how can I make sure that's the middle of this side over here?
Measure.
Okay, measure.
Oh, you can do the
Yeah, this right here. and then choose 2 lines. Okay, so let's measure our side here. Go to centimeter with the arrow under measure, and we can check from my N to my P is 6.1. So what do I hope P to O is? Also 6.1. Let's see. Yay! So it is my perpendicular bisector. So before we put in our other ones, let's go ahead and start with our notes. Go to media and click the ABC.
You make a segment over it, and then you
Hide it.
make the line.
Okay. So let's do our notes. What is a perpendicular bisector?
Yeah, what you did. I wish I could, bro. I really wish I could.
A line that intersects the side at a right angle and cuts it in half. Or I could have said at the midpoint. Might have sounded a little bit better. A line that intersects the side at a right angle and cuts it in half. Or at the midpoint. Alright, I haven't tried. Have we tried hiding the line yet?
Yeah.
Does it work?
Yeah.
Put a segment from P to Q. Hide that line. Make sure it's still. Oh yeah, there we go.
Wait. When mine goes over to, how does yours not go away? Because when mine goes, right.
As of right
When
now,
mine goes that way, it goes away.
Oh, you have to erase the line first.
But yours didn't go away when it, like, moved that way. It just went to the other side. Okay. So yours is still on the chart.
Oh, I see what you're saying. I don't know. Did you do your segment?
Yeah, I did.
Okay. All right, let's do it again. If you didn't get the first time, maybe we'll try the second time. See if it works. All right. So what button do we go to do the perpendicular bisector?
Third one on.
Yeah, under construct. Very good. So click a side, whatever side you're ready to do the perpendicular bisector for. There it is. You can confirm it by measuring the 90 degrees and seeing that it cuts it in half, or you can just trust it and let it be. Either way. Remember, we still need to make an intersection. So go to points and do the little intersection button. Intersect. Oh, I think I know what happened. I think I know what happened. I don't know that you can hide this. Let me do the other one right quick. Alright, we'll go ahead and do the other side. So let me Yep, mine's wrong.
It's starting to become a spider web where you show all the
Like, see how sometimes it goes on the outside? That's
Yeah.
obtuse. I think.
What is going on?
Hmm?
Oh, you moved the triangle.
Yep. So I went ahead. Sorry, I went ahead and did it for all the sides, and then now it looks all confusing because I don't have. Okay. So
here's how to do it. First, you make a line segment.
yes, he's right. So to
You do points, but after you put the points on there, then you create line segments between the points.
it gets confusing if you don't measure to let you know where it is.
I'm getting to that. After you create line segments,
Okay.
then
All right. So I'll help you hide. I went ahead and measured the 90 degrees so I could, because there's so many lines going on.
So
All right. So
that's why you do the high tool last. Unlike what you're doing right now.
you need to. So what you need to do is we're gonna hide this line, but we don't want this line to disappear from our triangle. So you got to get a segment from R, or let me do this one, from there to there. So make a segment from there to there, and also a segment from. So create these segments. So I'm making, see I'm in the segment line right there. So you're kind of making these segments. Okay. And then once you got your segments there, go to the show hide, which is under edit, the blue and white dot right there. And you can click the line, out here. And then, there you go.
Alright, I think we're gonna have to start this all over.
You did it. Good job, Michaela.
Yeah, so do I, which is why I'm confused by what in the world is like this.
All right, let's create. So if you need a little bit of help, okay, if your lines are still there, create segments that highlight the perpendicular bisectors inside here, and then go to show hide and click the lines outside, and it'll go away. All right, so go ahead and click the intersect button to create our point of concurrency right here. So intersect. Just click two perpendicular bisectors, and mine created V.
E1.
So let's change V to the official name. Nope. He had the same name of something else. It's called the Circumcenter. Circumcenter.
Yeah.
Circumcenter. Yeah, you just click the point, then the double A, and then you can change it.
If the main line is still not going to land that way.
Circumcenter.
I'm telling you, you have to. You're probably going to have to wind up starting over.
I know.
So whatever the world.
Circumcenter.
Well, you done goofed big time.
Circumcenter. All right. Does the circumcenter always stay inside of the triangle?
No.
Have we figured that out yet?
Yes.
I'm hearing yeses, I'm hearing no's. How can I figure it out?
By moving the triangle.
Oh no, where did it go? Where is it?
It dies when
It
you
dies.
get obtuse.
Very okay. So it doesn't die. It's out there, right? It's out there. Here he is. Okay. If I go back to show high, he's still out there, but
But there's other line intersections. How do you know which one is the real one?
well, I know. This is the one from up there at the ortho center, isn't it? Yeah. So it's still out there. So part of our notes needs to say that. So let's go ahead and add to our notes. You ready? All right. Let me try to zoom in for y'all. So first of all, let's define what the circumcenter is. What is it? Yes.
Yeah.
The
You are so polite.
the intersection of the
Perpendicular bisectors.
good.
I was gonna say you're right. You're right.
The circumcenter is on the inside of the triangle if the triangle is
Acute.
Right or acute?
okay. If it's right, where's it going to be?
On the triangle.
On the circle.
Let's check it. Wow.
That is a very. Yes.
Yes.
Oh,
Yep.
Everybody's worried about me, but I'll be okay.
Just making sure.
Not nothing else.
The circumcenter is on the outside of the triangle if the triangle
Obtuse.
is obtuse. The circumcenter
Everyone's worried about me, but I'll be.
is on the triangle if the triangle is
Zero.
all right. There's more. There's more. So make sure you got these. There's one more important thing we need to write about the circumcenter. It's very important, and it's actually important for your project. Okay? Everybody good on the notes?
No.
Okay.
The circumcenter is not at the center of the triangle.
It depends on what your definition of the center is. I've messed mine all up on my Zoom. What in the world is Falconberry? Help.
I meant to say negative. Never mind. I was like, never mind.
Yeah. So is that a yes?
All right.
That's the joke.
Where's my menus?
I
said
Jokes on you.
Yeah, jokes on you. See that name? What do you got? What's your name?
Oh, jeez.
So the circumcenter is like the ortho center, like it's on the triangle, it's right, and it's like the outside and outside.
Right. Where is my
The
menu?
circumcenter and the ortho center are never the same.
They're never the same?
No,
But they-
that's what
they
I'm
act
guessing.
similarly.
No, I'm guessing.
Okay.
That's what the other point is.
How do I get my menu back? This is what happens when I zoom in.
Wait, press Control 0.
This is the blue one.
Control 0
Yeah,
or Command 0?
Command 0.
Where is it? Thank you. You're so smart. Now, where is it?
Oh, do the zoom in and zoom out buttons right here.
So we'll zoom out.
Oh,
Aha.
there you go.
Aha. Oh dear.
That's how that can Command 0 resets the zoom.
Oh, that is very helpful.
So if like you accidentally zoom in too far.
All right, so my I tried to help y'all out there. Messed myself up. All right.
Good job.
Yes, good job. All right, let's get our last few things going here. All right. Yes, there is no homework. Right. But we got 5 minutes to get this last little bit. You ready? I would like for you to create a segment. You with me? Okay, create a segment from the circumcenter to the vertices. So to a vertex. So for instance, I'm going from I went to lines, I chose segment, and I'm going from the circumcenter to a vertex. Now, I'm adding more lines, which stresses people out, I understand. So go to your arrow and click that line, and let's make it dotted. Either dashed or dotted. So I click the segment, and then I click this little line right here, and whatever you want to do, you can make it dashed. Is that better? Make you feel better?
Yes.
Made my triangle dot. What does that have?
In your triangle, what?
Oh, it made it dotted. I
Oh,
didn't click on my
you clicked the
triangle.
wrong.
I clicked on the I clicked on the segment. Like, that's weird.
All right, do it again for the other vertices. So segment from the circumcenter to the vertex.
They're all gonna be the same length.
Okay, can you try
Circumcenter to the vertex.
Let's see. Okay, it's not
You have to do the line sequence first. Okay, alright.
Then click the line segment and make it dashed. Click the line segment, make it dashed.
this thing triangle. You know what? Get out of here.
So why do you think I did that?
I'm a magician.
Well,
You
they're
are.
not real, but
They're all the same length.
okay. So Ashley has a idea that maybe she thinks that these are all the same length. How could we test that theory?
By measuring them.
Yes, we can measure. So how do I measure a line segment?
By clicking on the centimeter with
Yes,
the lines.
the centimeter one right here. Let's check it. So click the centimeter measure, click a vertex, and then the circumcenter. So mine was 5.3, my first one. Then M to circumcenter, interesting, 5.3. Circumcenter to O, 5.3, very interesting.
Yay, mine are all set.
All right, did y'all get that part?
Yes.
So what am I trying to say?
The circumcenter to a vertex is all the same.
Very good. So we can use a fancy word. All right, add this to your notes and we're done. The circumcenter
The measure of the circumcenter
is fancy word. Y'all ready for a
to
fancy word?
vertices,
I don't like fancy schmancy words. This works.
The circumcenter is equidistant.
to each vertice.
I was
Yeah.
gonna say
Lateral.
I'm always like I've only done that word before.
The circumcenter is equidistant. Well, I mean, you can kind of tell what that means. That word means equal distant, right? So equidistant to the vertices of the triangle. So that was a hard one today.
You did it.
I don't
It's a
know
tough
if
one.
the first because I did the exact same thing. As
I
was
zoomed
doing.
in a little more before I did it.
I did the
EQUI.
exact same thing and it just didn't
I mean,
I was like,
see
You-
my,
you
I
must-
got 5.3,
It probably
5.3,
thought you
and
were clicking the
5.3.
triangle because you weren't zoomed in.
No, I want to show. I want to show.
I didn't do maybe.
All right, so if you've got this, you've got your point, and you should be up to 3 points by now. Tomorrow you get your 4th point and turn it in. So Make sure if you need to catch up, I've been screencasting. So if you